This video is for my pre-algebra classes. It's over lesson 34, proportions and ratio word problems. So first of all, ladies and gentlemen, let's define what a proportion is. A proportion is a statement that two ratios are equal. These ratios are usually written as fractions, so you can also think of this as a statement that two fractions are equal. So one way that we can tell if something is a proportion is if both ratios can reduce to the same ratio. Because if they're both equal to the same thing, then they must be equal to each other. So for example, 4 to 8, or 4/8, equal to 5/10, that would be a proportion, because both 4/8 and 5/10 reduce to 1/2. Now later on we'll learn other ways that we can tell that these are proportions, but this is just where we're going to start for now. Next up we have another vocab term, which is constant factor. So when you read this, there are two things that should stand out to you. First of all, constant should stand out. So constant means there's something that's going to not be changing. It's going to be the same. And then factor is the next thing that should stand out, and we should know that a factor is something that's being multiplied. So we're going to be multiplying by the same thing. That's what a constant factor will have to be. And it is a number that can be multiplied with both numbers of a ratio to make another ratio. So, by way of example, we know that 3/4 is equal to 18/24, because 18/24 would reduce to 3/4. Well, another way of looking at this is if I have 3/4, if I were to multiply this by 6/6, 3 times 6 would be 18, and 4 times 6 would be 24. There's my 18/24. And so I've just proved that these two things really are equal. If you multiply something with a form of 1, this will be equal to the result. Now by doing this though, I've just shown that the constant factor here is the number I keep multiplying by. Well, what number did you multiply the numerator by? What number did you multiply the denominator by? The constant factor here is 6. So essentially, what would you use in a form of 1 to create the other fraction? So, ladies and gentlemen, when it comes to proportions, it's always a relationship based on two equal ratios, and ratios are a division relationship. So if we think about our pyramid, our math pyramid, which we've talked about a little bit, on the same level with that pyramid, with division on the pyramid, is multiplication. And so we're going to have a lot of relationships between division and multiplication here. So one way of representing what we just saw, if I take our example again, 3/4 equals 18/24, is that we can think that to move from left to right, on top we multiply by 6, And to move from left to right on the bottom, we also multiply by 6. That'd be another way of representing what we've just talked about here. Let's take another example. Let's say 12/48, and we say it equals 3/12. So if I'm looking for a constant factor here, we're looking left to right, or we could go right to left, so basically crossing the equal sign. In this case, I might choose to go the other way and say, okay, well, 3 times 4 is 12. And do we see the same thing here? Well, 12 times 4 is 48. So yeah, again, we have a constant factor here. So let's go ahead and take our orange highlighter, because we highlighted that in orange. And we're just going to put a little box, an orange box around these. All right, let's take a look at another example here. I'm going to drop down a couple spaces. This time, let's go 5/15, and let's say that equals 25/75. Okay. Now, we should be able to tell very easily that these are a proportion, that this is a proportion, because we know 5/15 will reduce to 1/3. We know 25/75 will reduce to 1/3. We know it's a proportion. They both reduce to 1/3. But what is my constant factor? Well, 5 times 5 is 25. And we're going to hope that 15 times 5 is 75. Well, if you think about the clock, we know that each quarter of an hour is 15 minutes. So 4 quarters of an hour would be 15, 30, 45, 60. So if we go one more group of 15, 60 plus 15 more would be 75. So sure enough, 15 times 5 is 75. So my constant factor here would be 5. Now, ladies and gentlemen, proportions actually have a lot more flexibility than just what we see here. While it's true that these are the constant factors, there are relationships not just left and right, but up and down as well. And we can see that pretty clearly over here, that if we choose to go down, 12 times 4 is 48. Over here, if you go down as well, 3 times 4 is 12. So we see that match there. Now here's the question though. Will they always be the same all the way around the proportion? Will it be 4 left and right and 4 up and down? Well, if we turn to this example here, we're going to find out it's not. Because here, if we go down, 5 times 3 is 15. 25 times 3 is 75. Now this one, it's a little less obvious going up and down. But if we take a look, we can potentially piece this out. So I like to go from the little guy to the big guy, because then I can express things as multiplication. It is possible to express things as division though. But if I want to do this as multiplication, 3 times what would give me 4? Well, obviously, I'm going to have a times 1, because that's going to, 1 times 3 would give me 3. But then I need a little bit more. Specifically, I need 1 more. Well, 1 is 1/3 of 3. So if you have one group of 3 and then a third of 3, well, 1/3 is 3, and a third of 3 is 1. 3 plus 1 is 4. Over here, if we do the same thing, 1 of 18 is 18. A third of 18 is 6. Well, 18 and 6 makes 24. So while that's not as helpful, it's still true. So ladies and gentlemen, in a proportion, what we've just discovered here is whether we go left or right, there's going to be some relationship that is constant, and that's called the constant factor. So if I go from left to right, we're going to multiply by 6. So 3 times 6 is 18, 24 times 6 is 24. If we went the other direction, we would just divide. So 18 divided by 6 is 3, 24 divided by 6 is 4. There is also a relationship up and down. So over here, 5 times 3 is 15, 25 times 3 is 75. Go up, it just reverses to the division here. 75 divided by 3 would be 25, 15 divided by 3 would be 5. Now this doesn't have a special name, but it is true of proportions. So ladies and gentlemen, to go back a moment here, earlier we said 3/4 times 6 over 6 equals 18/24. To make a connection with something that we've learned earlier this year, we need to remember that 6 over 6 is special because it's a form of 1. Now do your best to try to make this block 1. Okay, I don't expect you all to be artists, but just do your best. So with that in mind, what we see here is that we're really just multiplying by 1. So what we're saying is we have some amount times 1 will equal, and we know that this must be the same amount. So because this is 1, we know that 3/4 must equal 18/24. And we know this because this is an example, it's an unusual example, but it is an example of what we call the identity property of multiplication. That when you multiply a number times 1, it still is the same number. So whenever you multiply by a form of 1, realize that this and the result are always equal. And that's the identity property of multiplication. So ladies and gentlemen, we're going to look at one more thing here, and then we're going to do some practice of this, and we're going to even look at how to solve some proportions using the skill that we just learned. So first up, we're going to answer a little question. Is 2/3 equal to 3/4 a proportion? And we need to explain. At this time, I would like you to go ahead and pause the video, and if there's somebody that you can talk to, particularly if you're looking at this in class, I want you to take a moment and discuss, is this a proportion? How do we know? How do we not know? All right, let's see how we did. And there can be many different answers here, and it is possible that you might have come up with a reason that I'm not going to list here, but I'm going to list several. So, no, it's not a proportion, because, and what I'm going to do here is I'm going to put an ellipsis, which is to say because, and then it kind of trails off and allows us to pick up somewhere else. And so my first because, and so I'm going to pick it up by doing another ellipsis. So one answer would be to say, because remember that if these were equal, they should be able to reduce to the same thing. But 2/3 and 3/4 are completely reduced. But not equal. So if we completely reduce both sides of a proportion, they should always be equal. So that's one possible answer. Another possible answer could be to look for a common denominator. So if I look for a common denominator, I might say, okay, with a 3 and a 4, common denominator would be 12. So 2/3 times 4 over 4 would give me twelfths, specifically 8/12. And then 3/4 would be times 3 over 3, which would give me 9/12. So we can clearly see once we have a common denominator that these are not equal. So 2/3 equals 8/12, 3/4 equals 9/12, which are not equal. If each one of them equals things that we obviously know are not equal to each other, then they're not equal to each other. Another option here would be actually to find a common numerator. And that's a little less common, but that is a possibility as well. So it's very similar to common denominator. So 2 and a 3, common numerator of 6. I'm not going to bother to write that, but that would technically be a possibility. Another common possible answer here would be to do something that is unusual with ratios, but we do it every once in a while when it is helpful, would be to take your ratios and change them into decimals. So 2/3, actually hopefully we have memorized, is 0.6 repeating. This is one of the few times that repeating decimals are allowed. Most of the time we try to avoid them. But here we're trying to give the decimal answer, and the decimal answer is a repeating decimal. So there's no way around it this time. Whereas if I take the 3/4, hopefully we have that memorized, that's 0.75. And so 0.6 repeating and 0.75, well, are obviously not equal. So comma, which are not equal. They equal different decimals, then they're not equal to each other. Another way to look at this would be to take advantage of the fact of kind of thinking through what would be the case if they were equal. Well, if they were equal, if you take a number and divide it by itself, it should be 1. So we're going to say no, because if 2/3 equals 3/4, then 2/3 divided by 3/4 equals 1. But does it? Well, let's do it. But 2/3 divided by 3/4 equals 2/3 times the reciprocal. And then 2 times 4 is 8, 3 times 3 is 9. But it does not equal 1. It equals 8/9. And again, there could be other answers there, but that's just a sample. All right, well, ladies and gentlemen, at this point in time, what I'd like you to do is pause the video for just a second to grab your books and open up to the practice problems for lesson 34. And that'll be on page 226. So go ahead and pause that and get that ready. All right, here we go. Starting with problem A. Which pair of ratios forms a proportion? So if we just look through these real quick here, A, we have 3/6 and 3/6 and 6/9. So if I just kind of do some thinking here, 3/6 and then 6/9. Well, I know 3/6 is 1/2, 6/9 is 2/3. Nope, not a proportion. If we look at C, we should be able to rule C out instantly. Because for one thing, 3/6 and 6/3, those are reciprocals. The only time that reciprocals are equal is if they're 1. We could multiply these together and get 1, but that's not what we're looking for. We're looking for these to be equal. So process of elimination says it must be B. But let's not just rely on process of elimination. Let's make sure it actually is a proportion. So if we think through this just real quickly, you should recognize that 3/6 is 1/2. You should recognize that 6/12 is also 1/2. And so if they're both equal to 1/2, they must be equal to each other. So the answer for part A is B. On to letter B. Letter B, how do you know your choice is correct? So we could say that 3/6 equals 6/12 is a proportion because, and since this asks us to justify, it asks us how do we know proper sentence. Now I'm going to put an ellipsis here, and we could answer similar to what we had up top, but this time we're saying yes. So we could say something about what they reduce to. So one possible answer here is to say that 3/6 reduces to 1/2, and 6/12 is equal to 1/2. Which are equal. 1/2 equals 1/2. And so if what they equal is the same, then they must be the same. Same value. So that's one possible answer. Another possible answer to go with what we learned on the front in the orange, the scale factor, if we look for a scale factor, or excuse me, a constant factor. So it is a proportion because 3/6 times 2/2 equals 6/12. So it has a constant factor of 2. Now, just to be clear on the homework, I wouldn't expect you to write all of this out, but what you would do is you would write out the beginning part of this, and then instead of the ellipsis, you would just choose one of these. So we could say 3/6 equals 6/12 is a proportion because 3/6 equals 1/2 and 6/12 equals 1/2, which are equal. That would be one possible answer. A second possible answer would be to use this starting again, and then to use this ending instead. All right, moving on to C. So now we're going to take a look at solving, and this is where we're going to use this idea of left and right relationship, the constant factor, and this up and down relationship, which doesn't actually have a nice answer. So when I look at the proportion 4/6 equals C over 18, for this to be true, then we need to find a value of C that 6 times something equals 18, and 4 times that same something is C. Or it could be that 18 divided by something gives me 6, and C divided by that same something gives me 4. Or it might be that 4 times something gives me 6, and C times something gives me 18. Or 6 times something gives me 4, and 18 times something gives me C. So again, it's going to have the same relationship of left to right, left to right. You're multiplying or dividing by the same thing. If we go right to left or right to left, multiply, divide by the same thing. Whether you're going up or down, multiplying by the same thing. So guys, in general, what we want to do here is we either want to move to the right or we want to move up. And the reason why I say that is because we really want to move towards C. We want to move towards that letter. And so since it's in the upper right, you either want to move to the right or you want to move up. So which one of these is easy to identify? And hopefully you've seen here that it's moving to the right. That's easy to identify because 6 times 3 is 18. So I don't really need to move up this time. I'm going to get rid of that. So if 6 times 3 is 18, then 4 times 3 is C. So therefore C must be, well, 4 times 3 is 12. We'll try this again with D. D, we have 9 over 3 equals 18 over D. Now this time, since D is on the bottom right, I either want to move to the right or I want to move down. So looking at it, which one stands out? Well, real quick, what catches my eye is the fact that 9 times 2 is 18. So if I move to the right here, again, I can multiply by 2. So we don't need to go down. So 9 times 2 is 18. So therefore, 3 times 2 should be D. Well, therefore, D is, well, 3 times 2 is 6. And this time, I'm actually going to do this again. Because if we look at it one more time, maybe for some of you, it stood out that if instead we move down, that 9 divided by 3 is 3. So therefore, 18 divided by 3 should be D. Well, 18 divided by 3 is 6. So there were two easy options here. There were two easy options here. All right, I'm going to come up here, and I'm running out of space down at the bottom a little bit. Well, I have room for one more. I got room for one. I'm going to put one more here. We'll put E here. So E over 9 equals 5 over 15. So E is in the top left. I'm not going to bother with the red this time. We'll just go straight to it. E is in the top left. So I either want to move up or I want to move left. So if I move left, I'm thinking 9 times or divided by, or excuse me, 15 times or divided by something gives me a 9. Now, we can figure that out, but it's not real obvious. So it might not be the best way to go. So instead, if we think about going up, 15 divided by 3, though, is 5. So then over here, it must be the same thing must be true. So 15 divided by 3 is 5. Then 9 divided by 3 must be E. So 9 divided by 3 is 3. I'm going to draw a line down the center of the page here. F, I have 4 over F equals 3 over 12. So F now is in the bottom left, so I either want to move down or I want to move left. So if we try to move left, then 3 times or divided by something has to be 4. That's not really easy. But if I move down, 3 times 4 is 12. So if I move down, I could times by 4. So if 3 times 4 is 12, then 4 times 4 is F. So therefore F must be 16. Now, ladies and gentlemen, word of caution here on these. Some of you may remember a different method for solving proportions, and I'm not saying that that's wrong. However, I do want you to practice this. This is a nice, very quick skill if you can catch something like this that comes out nicely. Now, unfortunately, our proportions are not always going to come out nicely, so we do need other skills to solve them when we have more complicated problems. But this is real nice if you can catch a break every once in a while and be able to do something just left, right, up, or down and solve quickly. All right, let's take a look at G now. G changes a little bit here from what we've been doing. So G says, a wholesaler offers discounts for large purchases. The table shows the price of an item for various quantities. Is the price proportional to the quantity? How do you know? Well, let's take a look here. With G, I'm actually going to make a table out of this. I'm going to say Q for quality, and then I'm going to say P for price, and I'm going to copy down the information that they have. So they have 10, 100, and 1,000. I'm going to put my comma in even if the book didn't. I'd like you to do the same, please. And then over here we have $30, we have $200, and then we have $1,000. And since it's asking if this is proportional, I'm going to add one more column. And in this column, I'm going to make a ratio out of everything. And so I'm going to put the price over the quantity. That's going to be my ratio, the price to the quantity. And so my first ratio will then be 30 over 10. My second one will be 200 over 100. And my third one will be 1,000 out of 1,000. And so if we simplify these, this first ratio is going to become a 3-to-1 ratio. This is a 2-to-1 ratio. And finally, this is a 1-to-1 ratio. So to answer the question, is the price proportional to the quantity? Well, what we've just shown here is it is not. Because in order to be proportional, we would need to have equal ratios. It's a statement that ratios are equal. So no. No. Is not proportional. And then we're asked, how do we know? So because, as we just showed here in the table, because the reduced ratios are not equal. The reduced ratios are not equal. All right, here we go. I solve problems I and J by creating a ratio table and writing a proportion. So for I, a ratio table is going to be a box from which we'll make our proportion. And so in our box, we will have the first column be ratio, the second column actual. And there's our ratio box. Now we got to actually read the problem to figure out how to fill it in. So the ratio of the length to the width of a rectangular room is 3-to-5. Or sorry, not 3-to-5, I'm sorry, 5-to-4. So that is the ratio of the length to width. So length is often symbolized with a cursive lowercase l. We make it cursive so that it doesn't look like a 1. And then a W is usually what we use for width. And so that cursive lowercase l, by the way, is the only time in my class that I require cursive. Nowhere else. I often write with cursive, you see, but you don't have to except for that L. Write that in cursive. So we're told we got a length and a width. Those just became my rows. And the ratio was a 5-to-4. Okay, keep reading now. If the room is 20 feet long, all right, stop right there. It is 20 feet long, so it's actually long. How long? 20 feet. Question? How wide is the room? So we don't know the actual width of the room. Well, ladies and gentlemen, if you were to imagine that these were all stickers and peeling off the ratio sticker and the actual sticker, the L and the W, and then peeling off each one of these lines, you'd be left with, and I'm going to put this up here just so we got plenty of room. Oops, sorry. You'd be left with a 5, a 4, a 20, and an X. That's your proportion. Just put in the appropriate symbols. Put in your fraction bars, put in your equal sign. There's your proportion. Now to solve this, okay, think left, right, up, down. What would be easy? So it's in the bottom right. So I either want to go down or I want to go right. So going down would require me to do 5 times or divided by something gives me a 4. That's not very nice. But if I move to the right, 5 times 4 is 20. So I like the idea of moving to the right here. So I'm going to put my arrow here and my times 4 just real tiny there. Times 4. That saves a little bit of room. So 5 times 4 is 20. Therefore, 4 times 4 should be x. So therefore, x is 16. Now, this comes from a story problem, though, so 16 what? 16 poodles, 16 chihuahuas, 16 pomegranates, 16 what? Well, 16 feet. That's how wide the rectangular room is. All right, and I just barely have enough room here for J. We're going to squeeze J in. The teacher-student ratio in the primary grades is 1 to 20. So timeout right there. I'm going to make my box. I know the first column is always ratio. I know the second column is always actual. And it's talking about the ratio, the teacher-student ratio. So teacher is first. Student is second. The teacher-student ratio. So look at your ratio now. So the first number is going to be the teacher number, second number is the student number. So the teacher number is 1, the student number is 20. If there are 100 students in the primary grades, stop right there. There are actually 100 students. How many teachers are there? So we don't know the actual number of teachers. So again, imagine peeling up all these words and the lines. We'd have a 1 and a 20. We'd have an X and a 100. Well, put in your fraction bars, put in your equal sign, and there we go. Now, we can either go right to left, or excuse me, we can go to the right, or we can go up to get towards X. So if I've actually got some nice options here. If I go to the right, this will be 20 times 5 is 100. If I go up, then 20 divided by 20 is 1. And, just to mix things up, I'm going to go up this time. I'm going to divide by 20. So 20 divided by 20 is 1. So 100 divided by 20 should be x. Therefore, x is 5. Oh, but 5 what though? X was in the teacher row. So actually, we need to amend this and make it 5 teachers. And that, ladies and gentlemen, is our lesson.